So today we want to talk about limits of transcendental functions. And transcendental functions are basically just functions that are not algebraic functions. So exponential functions, trigonometric functions, inverse functions, you're familiar with these, but now we want to actually be able to find the limit of them. So in front of us we have some exponential functions, and we want to find our limits as they go to negative infinity and infinity. It looks like we're kind of talking about here. So here, looking at part A, we are saying as x goes to negative infinity, we're going out to the left. It looks like f of x is going to negative 3. And for as x goes to infinity, we're just going up and up and up forever, so we are going towards infinity. Now if we look at B, this looks like we have a decay function here. As x goes to negative infinity, we're actually going up towards infinity. And as x goes towards infinity, looks like we're getting closer and closer and closer to that asymptote, which happens to be at negative 3. So now if I go down and look at parts C and D here, if I look at part C, I can see that the limit as x goes to negative infinity, I'm going to get closer and closer and closer to 2, where our asymptote is. And as x goes to infinity, I go on and on and on forever. I'm actually going towards negative infinity. Now, if I look at letter D, the limit as x goes to negative infinity, I go on forever towards negative infinity. And as it goes towards infinity, I get closer and closer and closer to that asymptote at 2. So what does this mean? Really, kind of what's happening? Well, if we look here, there are three things that happened. Either our end behavior went towards negative infinity, or our end behavior went towards infinity, or our end behavior went towards a horizontal asymptote, which I'm going to call A. Went towards A, our horizontal asymptote. So horizontal asymptote. And in this situation, y would be equal to b. Now, I just want to write a reminder here that the form for an exponential function is in the form y equals ab to the x minus h plus k, right? So I have this. I either went, I'm sorry, I don't want to call this A, the horizontal asymptote A. I either went towards a horizontal asymptote. I'm just going to leave the A out there. And in this situation, y was equal to b, where b is the horizontal asymptote. Sure, there, that's better. Okay, so let's kind of summarize some of this in a graph here. I'm going to switch over pages. I'm a little bit out of order, but hopefully you can forgive me. So if you go back and look at those graphs, well, that first graph we did, letter A, this was letter A, this was letter B, C, and D. This first graph, it had growth. And it had how many reflections? Well, in this case, B was greater than 1. It had no reflections, none. The reflection happens when we have negatives, right? So if I go back to this equation here, if A is negative, or like there's a negative here up in front of x, that's when a reflection is going to occur. So as you can see, at part A, we had no negative here, we had no negative here, so we don't have any reflections. So what were our limits? Well, the limit as we went to negative infinity was negative 3, and the limit as we went to infinity was infinity. Now, let's look at part B, our second graph that we talked about. That was a decay. Oops, decay. Spell it correctly. That was decay. And here we actually had no reflections, but in this situation, B was between 0 and 1. Take something to take note of. Ugh, sorry, I'm smudging all over the place today. The limit as we went towards negative infinity was infinity, and the limit as we went towards infinity was negative 3. For letter C, we again had decay. In this situation, A was less than 0 and B was greater than 1, and we actually did have one reflection there. Our limit as we went towards negative infinity was 2, and as we went towards positive infinity, it was negative infinity. And finally, part D, we had growth. A was less than 0, and B was actually between 0 and 1, and we had one reflection. So as we went to negative infinity, we went to negative infinity, And as we went to infinity, we went to 2. So let's kind of summarize this information here. Well, if, I'm going to go back here, if we have growth, our values of b can either be between 0 and 1, or they can be greater than 1. Same for decay. Our values of b can be between 0 and 1, or b can be greater than 1. And when we have growth, our number of reflections, when b, is between this, we're going to have 1. And if it's greater than 1, we're going to have either 0 reflections or 2 reflections. Now with decay, if b is between 0 and 1, that's when we're going to have 0 or 2 reflections. But we would have 1 reflection if b is greater than 1. So what can we do with this information? Well, let's look here. We have the limit, looks like this is actually going towards, negative infinity. The limit as x goes towards negative infinity of negative 0.3 to the x plus 2. Well, in this situation, a is less than 0, so I have 1 reflection, right? And here, b is between 0 and 1, so I have growth. So I can go up, I see, okay, so a is less than 0, so I have 1 reflection, and b is here, is growth. So that's what's going on. So I can kind of draw that, right? I can kind of roughly draw this. Y is equal to 2. Here's my intercept, so this is going to look something kind of like this. So now I can find my limit. As we're going towards negative infinity, what's happening? Well, we're going towards negative infinity. All right, let's do another one. So for the second example here, looks like b is going to be greater than 1. B is equal to e. Right? And we have a negative x, so then we're going to have 1 reflection, right? And if I go up to my chart here, b is greater than 1, and I have 1 reflection, I'm going to have decay. So I can write that down. I have decay. So I can draw this again. I've kind of got a graph. Looks like here, negative 3 is that. I don't really know exactly what this looks like, but I know it's going to be something like this. So as I'm going towards negative infinity, I'm going up and up and up forever. So I'm actually going towards positive infinity. That's my limit. Let's do another example. Example 3 here. We've got the negative 1/3. The limit is x goes to infinity of negative 1/3 to the negative x plus 1. Well, in this situation, x is less than 0, right? Because we got a negative x there. A is less than 0. B is between 0 and 1. So because I have a negative here and a negative here, I actually have 2 reflections, right? And so actually, if I have 2 reflections and I'm 0, 2, I've got decay here. So I can draw this again. My asymptote is going to be at 1. This is ugly, but we get it, right? Here and here, what's going on? Okay, and now I need to actually find my limit. As I go towards infinity, what's going on? Well, I'm going to go to negative infinity. All right, let's do one more. Here we've got the limit as x goes to 2 of e to the x minus 3 of negative 2. Well, in this situation, b is greater than 1, right? B is e there. And actually, x is going to 2. So really, with this situation, I don't really need to figure out things. I can just do this as a regular limit. So I'm going to say here, I'm going to have e to the 2 minus 3 minus 1, which is e to the negative 1 minus 1. So I'm going to have 1 over e minus, and if I want to rewrite 1 as e over e, then I can rewrite this all as 1 minus e over e. All right? So don't let that kind of trick you up very much. So let's actually now talk about trigonometric functions. And these are some of my favorites. We do them a lot in calculus, and we're going to keep doing them. But here we have the limit as theta goes to pi over 3 of cosine of 2 theta over theta. We can do this just using direct substitution, like we've done other limits before. So here we're going to have the cosine of 2 times pi over 3 over pi over 3, which, well, is going to become the cosine of 2 pi over 3, which is a negative 1/2 over pi over 3. And if we simplify this all up, it looks like we're going to get negative 3 over 2 pi. Beautiful. Easy peasy. What about here? We've got our limit of sine of theta minus 1 over cosine squared of theta. And this actually, it's hard to see here, but this is going towards 0. Looks like I smudged it earlier when I wrote this. So let's just do some direct substitution. This is going to be the sine of 0. Oops, I tried to write it as theta. It's not theta anymore, it's 0. Minus 1 over cosine of 0 squared. Well, the sine of 0 is 0, so we're going to have negative 1 over 1 squared, which is just equal to negative 1. So simple and easy. So let's move on, make them a little bit more complicated. That's always fun to do, right? What if we have here the limit as theta, oops, theta goes to pi over 2 of 2 cosine theta cotangent theta. Well, this is not quite as direct, so we might have to rewrite this a little bit. And I'm going to rewrite this as the limit as theta approaches pi over 2 of 2 cosine theta over sine theta, right? I can use my trigonometric identities, which you are familiar with already, to just rewrite cotangent as cosine over sine. So now this is equal to 2 times the cosine of pi over 2, quantity squared, right? I've got cosine and cosine there, all over the sine of pi over 2. So cosine of pi over 2, just 0, right? So we've got 0 over 1, that's just going to be 0. If you want to take a moment to pause and try this one right here, I recommend that, but I'll dive into it right now. Here we have the sine theta cosine theta over tangent theta, and that limit is approaching pi over 4. So I'm going to rewrite this as the limit as theta approaches pi over 4 of sine theta cosine theta over, and you know what this is, sine theta over cosine theta. Right? So we can rewrite that as cosine theta over sine theta, right? And we're going to cancel some stuff out here. So now we just have the limit as theta approaches pi over 4 of cosine squared theta, which is just pi over 4, the cosine of pi over 4 squared, which is just radical 2 over 2 squared, which is just 1/2. Right? Beautiful. So what's going to happen when you do direct substitution? Well, one of three things. Either you're going to get like a number value, which is normal, straightforward, or you're going to get a number over 0, or you're going to get 0 over 0. And these two situations are a problem. These are indeterminate forms. So you might need to look at one-sided limits. You might have to use infinity, negative infinity, does not exist. Or you might have to simplify this. But be aware that number over 0 and 0 over 0, those are going to be issues and something that you should be looking at, right? So we actually have two special trigonomic limits. Limit is 0, or as theta goes to 0, of sine theta over theta is equal to 1. That's one I want you to remember. And the limit as theta goes to 0 of 1 minus cosine theta over theta, that's equal to 0. That's another one I want you to remember. So let's actually practice using these to solve some, limits of trigonometric functions. Here we have the limit as theta goes to 0 of 3 sine 5 theta over 2 theta. Well, I'm going to rewrite this as the limit as theta approaches 0 of 3 times the sine of 5 theta over 2 times theta times 5 over 5. Okay. So now this becomes the limit as theta approaches 0 of, I'm going to take that 3 times 5, now I get 15, over 2, I'm going to leave that 2 there because now I have sine 5 theta over 5 theta, and that should look a little bit familiar up here, right? So our answer now, sine theta over theta, that's going to work out to just be 1. This limit is just going to be equal to 15 halves. Good? Let's do another one. here we have 1 minus the cosine of theta plus sine 3 theta over theta. Well, I'm going to rewrite this as the limit, as theta approaches 0, of 1 minus cosine theta over theta plus sine of 3 theta over theta. And I'm actually going to, I did not rewrite that very well. Let me erase this, because I should be neater with my mathematical notation. I need to rewrite this as plus the limit as theta approaches 0 of sine of 3 theta over theta. And now I can multiply this 3 theta over theta times 3 over 3. So the limit of 1 minus cosine theta over theta, we know that that's just 0. So now this is equal to 0 plus this is just going to be equal, that sine 3 theta over 3 theta, all that cancels out, is just 3. So my answer here is 3. So that's pretty much it. That's exactly how that works, and hopefully that makes sense to you, and we will work on it in class our next day. Thanks.